So welcome to our lesson in section 11.5, and the title of this is Equations Reducible to Quadratic. So what we're looking at doing is taking equations that may not necessarily contain a x squared or a v squared or a t squared variable, but we can do what's called a substitution to somehow rearrange it so that we can rewrite it as a quadratic equation and then solve that quadratic equation that results, and then use those solutions to obtain the answers to the problem. I know that sounds like a mouthful, but this will make sense as all of these problems unfold. So we're going to take a look at some problems in this section to see exactly what this looks like. So we're going to go ahead and start with problem number 16. And the original problem reads, x to the fourth minus 10x squared plus 9 is equal to 0. So when we're looking at problems like this, you'll see that this is something that is x to the fourth. It's not an x squared quantity. What we need to do is somehow rewrite this so that we obtain that. So we're going to do something that those going on to calculus are going to see again, what's called a U substitution. And what we're going to do is, if we have any quadratic expression, or any equation that contains three terms, where you have something raised to an exponent, the following term has something raised to half of this exponent, so half of 4 is 2, and then you have a constant term and it's set equal to 0. We can usually rewrite it in the following way. So we take a look at the middle term, as this is written in descending order, and we take a look at x squared. We're going to go ahead and let u equal x squared. So that is the beginning of the substitution. So now if I take u equals x squared, and I go ahead and I square it. I square the u, and then I squared x squared. Well, u squared will obviously be u squared. And then x to the second is going to be x to the fourth. So now we have a way of representing x to the fourth here as u squared, and we have a way of representing x squared as u. So you're going to see that when we look at problems like this, it's always going to be when we have this not quadratic equation, but this equation that looks similar to a quadratic equation, where we have these exponents where they go in decreasing order, starting with the largest exponent to the next smallest exponent to no exponent. When it's written in that order, you'll find that we do the u substitution in pretty much the same way. So we have this substitution we're going to come back to and look at in a little bit. So I'm going to go ahead, and for x to the fourth, I'm going to write u squared now. So I'm replacing x to the fourth with u squared. Now for x squared, I'm going to go ahead and replace that with u. So u squared minus 10u plus 9 is equal to 0. So by doing this substitution, I can now take the original equation that was raised to the fourth, and I can write this as a type of quadratic equation, which should be pretty easily solvable. So if I have u squared minus 10u plus 9, I can factor this into u minus 9 times u minus 1, and I set that equal to 0. From that point, I go ahead and set each factor equal to 0. I'm going to add 9 to both sides. I'll get u is equal to 9, and here I'll get u is equal to 1 by adding 1 to both sides. So at this point I have these two solutions for u, but remember, the problem isn't asking us to solve u, it's asking us to solve these values of x. And just like most quadratic equations where we have some type of x squared term or t squared term, whereas most of these have two solutions, something raised to the fourth will often have 4 solutions. Not at all uncommon. Sometimes there may be a double solution, but let's see how we obtain that here. So here we have u is equal to 9. Here we have u is equal to 1. So we also know that from here that u is equal to x squared. Since I know that u is equal to x squared, I'm going to go ahead and sub x squared back in for u. So I'm going to write this as x squared is equal to 9. And over here I'm going to write this as x squared is equal to 1. I don't want to solve for x squared, I want to solve for x. So in order to do that, for the first example here, I'm going to go ahead and write the information twice, but I do encourage you to pause the video and just kind of record the work in the same manner I'm doing now. So like for example, I show this original substitution, I show the work, I show the outcome. Here I'm going to show the substitution. Here I'm going to show taking the square root of both sides here, and then I'll show the work below. That way we kind of preserve this step without messing with the substitution, so that's easier to see for the problem. Now that I take the square root of both sides, I'm going to have x equals plus or minus 3. And when I take the square root of both sides here, I'm going to have x is equal to plus and minus 1. So for this problem, I have 4 solutions. Now, they may ask for it to be written in this way when you work in MyMathLab, or more likely they're going to probably want you to say that x is equal to negative 1, 1, negative 3, and 3. So because this is an equation that is written to the 4th exponent, we have 4 separate solutions for it. Now, that's not always the case, but it often will be the case. So let's go ahead and continue to work through some of these problems, because each type of problem will present some type of twist to it. So let's go ahead and take a look at one more such problem. We're going to go ahead and take a look now at question number 20. Question number 20 is going to be 9t to the 4th minus 14t plus 5 is equal to 0. Well, unlike the other problems where we have this like a coefficient of 9, we're able to factor or somehow reduce this to get this to be 1. We're not going to be able to do that here. But that's not going to be our first concern. What we're going to go ahead and look at first is we're going to do a u substitution here. And by the way, this should be a t squared. If this was like a t to the 4th and this was just t, we wouldn't be able to use this technique with the problem. So we have t to the 4th, or 9t to the 4th, minus 14t squared, plus 5 is equal to 0. So I'm going to let u equal t squared. So again, copy this down and then write down the next work. So I'm going to square u, and that's going to give me u squared is equal to t to the 4th. So I'm going to do the substitution in here now. We're going to have 9u squared minus 14u plus 5 is equal to 0. So now at this point you may wonder, okay, how am I going to factor this god-awful equation? Well, for those of you who are good at factoring these kind of things, you may rely on something like the quadratic formula, for example. For a number of students in classes, it's probably going to be the likely route that students are going to take. And as a matter of fact, given the type of solution that we are going to obtain here, I think we have no choice but to go with the quadratic formula. So we're going to go ahead and go with the quadratic formula at this point and obtain the values of t with it. So what we're going to have now are going to be, let's see here, we have x equals negative blank plus or minus the square root of blank squared minus, whoops, and that's going to be a blank. Well, let's try that one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's go ahead and put this information in now. Negative 14 is going to go here and here. We have a being equal to 9 and 9, and then c is equal to positive 5. And only because we have this written in quadratic form now can we use a quadratic formula. So we have x equals, that's going to be 14 plus or minus, we're not sure what's going to go here yet, but we know down below we're going to have 18. So we can expect that the answer to this could be just a little messy, but we'll go ahead and we'll see how this kind of reduces. So from here, let's take a look. We've got 14, so let's figure out this discriminant, we call it, and maybe make some room over here for that. So we have negative 14 squared minus 4 times 9 times 5. So when we do that here, negative 14 squared is going to be 196. Bring the minus down. 4 times 9 is going to be 36. And 36 times 5 is going to be 180. Ooh, and that doesn't look quite as bad as maybe we originally thought. So we're going to go ahead and this one, and let's see, 190 minus 186. That's going to give us a value of 16, which is going to equal 4. So at this point here, we've got 14 plus or minus 4 over 18. So when we write this out, let's see, this will be, for a solution, 14 plus 4 over 18. And this is going to be 14 minus 4, or 14 minus 4 over 18. So 14 plus 4, that's going to go ahead and give us 18 over 18, which will equal 1. 14 minus 4 will give me 10 over 18, and that's going to reduce to 5 over 9. So we have two solutions here, 1 and then 5 over 9. So now that we have x equal to 1, and we have, not x, I'm sorry, I'm not solving for x here. Be careful of this, I'm solving for u. So watch out when you're writing your work on this here. Old habits die hard, and when you're used to having this formula, especially when you have the song with it, it's easy to mislabel an x as a u. So we have u equals 1 and u equals 5 over 9. The reason it's important to have the correct letter here at this point is because in place of u, you're going to go ahead and put t squared, what you originally had. So we're going to write t squared is equal to 1, and then t squared is equal to 5 over 9. Again, copy this down, and then copy it down one more time. So when I copy the square root of this, I'm going to have t is equal to plus or minus 1. And then when I take the square root of this, I'm going to have t is equal to plus or minus, well, I can't do anything with 5, so I'm just going to leave this as a square root of 5. But I can write the square root of 9 as 3. So I do have 4 solutions to this problem. And even though, yes, I could have factored this after all, and yeah, because all we would have had to do is pick negative 9 and negative 5 to get a sum of 14. We could have factored this. It's good that you see at least one where the quadratic formula is utilized as part of this process, as you may choose to utilize that depending on the level of difficulty of the question. So these are just 2 examples of how we handle something that is t raised, or that has some variable raised to the 4th. There are a few other variations that we need to further explore. Let's go ahead and continue to look at that. So the next problem we're going to look at is going to be question number 22. So I'm going to try 1 to 2 examples of each of these because the general gist of this is going to be the same. There's not going to be a fundamental difference in this procedure, generally speaking. So 22, we have s plus 3 radical s minus 40 is equal to 0. So this is not a 5, this is an s. S plus 3 radical s minus 40 is equal to 0. So, just something to keep in mind, this s is an s that's raised to the 1st. This is an s that is an s raised to the 1/2. So, so this is indeed half of this in terms of the exponent. So this looks all good. So let's go ahead and do a u substitution. We're going to let u equal radical s. You may also, if you want to, you may also write it as u is equal to s to the 1/2. Now, once you take this, I'll just go with radical s on top. If I go ahead and I square this, I'm going to get u squared. The square root and the square undo each other and give me s. So u squared is going to equal s. And then we're going to go ahead and do these substitutions in to here, where this is going to be u squared plus 3 times u minus 40 is equal to 0. Well, at this point, I'm going to go ahead and factor this. We're going to have u plus 8 times u minus 5 equals 0. I'm going to set each factor equal to 0. And when I subtract 8 here, they give me u is equal to negative 8. When I add 5 here, u is going to equal 5. So here is one important concept to kind of take away here because what we are going to do is we're going to replace u back with its original value, the square root of s. So we're going to have radical s is equal to negative 8, and then radical s is equal to 5. So whenever you see a square root or an even number root yield a negative number, know that this is not possible in the real number system. And in this question, they're asking you to only find real numbers for this. So when we look at something under a radical, at least when it's a square root like this one is, equaling negative 8, we have to know that this is not possible, and therefore we're going to reject. So I'm just going to put one line through that, so don't obliterate it, just show me what you got so I know you did it correctly. Over this one here, we can see what this is. So now we have the square root of s is equal to 5. Well, I want to know the values of s. So when I go ahead at this point, and I'll write this again, and I square both sides, I'm going to have s is equal to 25. And this is going to be my one and only solution to this problem. And after all, it does in fact make sense. Not always, but usually, since you have this raised to the only one exponent, there only happens to be one solution for this. Now, sometimes there could be two, but usually for these, it works out that one of these will disappear. So you have to check for that, and you have to be careful. So let's go ahead. We're going to kind of jump a little bit. We're going to go ahead and take a look now at 26. So we're going to look at a similar question now, in question 26. And let's see what this has to offer us. So this is going to be s minus 4 radical s minus 1 is equal to 0. And let's see what this has to offer us. Again, we're going to do exactly the same substitutions before. We're going to let u equal radical s. U squared will equal s. Now you see here I'm not going through the trouble of squaring everything, I'm just going straight to the substitutions. I've already shown 3 examples of that. As I need to, I will keep doing this as we switch to different types of questions. At this point now, I'm going to write this as u squared minus 4u minus 1 is equal to 0. You may see at this point that this is a problem in which you can't use factoring to solve. So we're going to go ahead and go to the quadratic formula. For some of you who are real big fans of completing the square, you are certainly welcome to use that technique if you'd like. So this is going to be negative 4. This will be negative 4, and by the way, that's going to be squared. This will be 1, 1, and this is going to be negative 1 here. Watch that negative. You can get the whole problem wrong based on that miscalculation alone. So we have here x equals minus a negative will give us 4 plus or minus, and this is going to be 2 below. Well, let's see. 4 squared is 16. Negative 4 squared is 16 also. This will be 16 minus a negative 4, or 16 plus 4. That's going to give us, and you can figure this out, is going to be plus or minus radical 20. Which I can further simplify. Let's go ahead and put that down here. 4 plus or minus 2 radical 5 over 2. So don't try to simplify this just yet. Let's go ahead and take a look at what answers we get. So if I write this out, this is going to give me 4 over 2 plus or minus 2 radical 5 over 2. So this is going to reduce to 2 plus or minus radical 5. So then that means we have 2 solutions to this for, and again, it's not x, it's going to be u we have 2 solutions for. Got to watch out for this. So we have u is equal to 2 plus radical 5, and here we have u equals 2 minus radical 5. Okay. So, and here's where you got to be careful, and here's where a little math sense goes a long way. If you're looking at the question here and you want to square both sides, the problem with this answer, radical 5 is greater than 2. So if you have 2 minus this, this is going to be, this value u here is less than 0. And therefore we're going to reject this. So just one thing to be cautious of when you're looking at a question like this. However, 2 plus radical 5 is not going to be. So we're going to go ahead and substitute in the square root of s for this. And if I square both sides, I now have to square 2 plus radical 5 times 2 plus radical 5, and that's going to give us a little, bit of a bigger number. That'll give me s. Well, let's go ahead and square that over here now. 2 plus radical 5 times 2 plus radical 5. This is 4. This is 5. This is 2 radical 5. This is 2 radical 5. So let's see, 4 plus 5 is going to be 9. 2 plus 2 radical 5 plus 2 radical 5 is plus 4 radical 5. And this is going to be our one solution again for question number 26. Let's go ahead and take a look at some more variations of this question. So that's really variation 2. The first set of problems we had something that began with x to the 4th or t to the 4th. Here now we have just an s, and we see what we have to do with the solution later by putting back that original substitution from u equals the square root of s, and then squaring both sides. But also noting that we have to look to see if we need to eliminate a solution in this case from the quadratic that resulted. So let's go ahead and take another look at another variation of this question, or at least another couple of these problems. We'll look at question number 24. This is going to give me x squared minus 2 squared minus 12 times x squared minus 2 plus 20 equals 0. So most students see this as like, oh no, it's not so bad once you do your substitution. What looks bad here is we have this x squared minus 2 term. We have this quantity squared minus 12 times this quantity plus 20. It's the x squared minus 2 that we're going to let equal u. So we're going to let u equal x squared minus 2. Now, watch this. This is important. So again, I had said I would walk you through this when I needed to. So I'm going to go ahead and I'm going to square this, and I'm going to square this. So u squared is going to equal. Now, I'm not really going to square this. I'm just going to write it exactly like this. I'm going to leave it like so, because that's what's going to help me most with the substitution. Do not expand this. That's where students often make mistakes when they first try this type of a question. So let's continue to look forward and see what we get. So when I sub in, it's going to be u squared minus 12u plus 20 is equal to 0. So once we have that, boy, doesn't that look a lot nicer. So we're going to go and factor that. And that's going to give me, let's see, u minus 10 times u minus 2. And that multiplies a positive 20, but adds a negative 12. So u minus 10 is going to equal 0. U minus 2 is going to equal 0. And for this problem, it looks like we're going to get u equal to 10, and then u equal to, positive 2, not negative 2. So you notice here I don't add 10 to both sides to get this, and I don't add 2 to both sides to get that. I'm hoping that is pretty straightforward for everyone to do. So at this point, I know that u is equal to x squared minus 2. So I'm going to go ahead and I'm going to take this x squared minus 2, put that here and here. So I'm going to get x squared minus 2 equals 10. Then x squared minus 2 is equal to 2. So you notice here that the work in the middle is generally speaking the same. The u substitutions are done very similarly, although they have a slightly different flavor in each problem. And we notice when we substitute the original value of u back into the problem, that's the same. But the resulting work varies at the end. And this is what I'll make sure you have some opportunities to see. So in place of u, we put the x squared minus 2. And now I'm going to get x by itself and solve. So here I'm going to add 2, add 2. So we get x squared equals 12. Here I'm going to add 2, add 2. And get x squared equals 4. And much like the problems we had before, we're going to go ahead at this point and take the square root of both sides. So for the first one, I'll go ahead and write this one more time. I'm going to take the square root of both sides in each of these. So I'll get that x is equal to, now the square root of 12 simplifies to 2 radical 3. But it's going to be plus or minus 2 radical 3. So yes, I'm doing two things at the same time here. and this is going to be x is equal to plus or minus 2. So now I've got my 4 solutions to the problem in question number 24. The next question I'm going to do that has a similar flavor to this one is going to be question number 28. So the way the book has this laid out, it's a little jumpy, so I'm hoping that everyone can follow along okay. But let's take a look and see what this question looks like. 3 plus radical x squared plus 3 times 3 plus radical x minus 10 is equal to 0. Well, let's see what happens when we work on a problem like this. I'm going to go ahead and I'll let u equal 3 plus the square root of x. Then u squared is just going to equal this quantity squared. Notice I'm not squaring it. I just want to do the substitution. So this will get us u squared plus 3u minus 10 is equal to 0. So when I do the factoring to this, I'm going to get u squared, let's see, plus 3u minus 10, looks like that's going to be u plus 5. It's going to be u minus 2 equals 0. Looks like I get u is equal to negative 5, and I get u is equal to positive 2. So what I'm going to do now, since I know that u is equal to 3 plus x, let's see what we get when we put u, or 3 plus x, back to here and here. So we have 3 plus radical x is equal to negative 5. And here we have 3 plus radical x is equal to 2. When I subtract 3, here I'm going to get radical x is equal to negative 8. When I subtract 3 here, I get radical x is equal to negative 1. So we're in a bit of a quandary. As we said in the last set of problems, you can't take the square root of something and obtain a negative number. This is not possible, even with I. Because you can't take the square root of something and produce something negative. You can get an I, but you can't get a negative value. And because we're looking at both negative values here, we have to reject both of these and say that to 28, there is no solution. Very different than many of the types of questions that we often see. So we have 3 more variations of questions to look at. We won't do a couple of each. We'll probably do about 4 to 5 more to wrap up this lesson. Let's continue to go forward, and let's see what this section has for us in store next. So we're going to go ahead and take a look at 32. This is going to be t. Actually, no, let's go ahead and take a look at 30 first. We're going to look at 30. Sorry for the jumping around. This is going to be 2x to the minus 2 minus x to the minus 1 minus 6 is equal to 0. So again, in a question like this, we're going to do u substitution, where we're going to let u equal x to the minus 1. If we square both sides, we would then say u squared is equal to x to the minus 2. And then let's just do the u substitution. This is going to be 2u squared minus u minus 6 is equal to 0. So now, depending on how good you are with your factoring, we're going to look for is, let's say I want to find 2 numbers here. This is going to be 2 and 6. So I'm going to let this be 2u. I'll let this be minus 2. I'll let this be plus 3. I'll let this be u. And yeah, those are the correct factors. Now, if you did not know how to factor this, you can use the quadratic formula. I'm going right to the chase here to save time in the lesson, but feel free to use the quadratic formula to solve this if it pleases you. So, and let me just double check. Yes, that's going to work out fine. So I'm going to set each of these factors equal to 0. And let's see, if I go ahead and subtract 3 from both sides here, this will be 2u equals negative 3. And then if I divide by 2, u will equal negative 3 over 2. Here, if I add 2 to both sides, u equals 2. So, how do I handle the substitution in this case? I know that u is equal to x to the negative 1. So what I'm going to do is I'm going to replace u with x to the negative 1. equals negative 3 over 2. And over here, this is going to be x to the negative 1 equals 2. So a couple ways that you could handle this. What I recommend simply is raising everything to the negative 1. If I raise x to the negative 1 to the negative 1, negative 1 times negative 1 is 1, so it's going to be x. If I raise negative 3 halves to the negative 1, what's going to disappear is the negative on the exponent, not the negative in the problem. Instead of negative 3 over 2, it's going to read as x equals negative 2 over 3. Remember, I flipped the fraction to get rid of the negative on the exponent. Over here, the x value is going to be 1. 2 to the negative 1 is going to be x to the, put it over 1, x to the 1 half. So we have two solutions to this problem. We have x equal to the negative 2/3, and then we have x equal to 1 half. So these are our two solutions to this problem here. Let's keep going forward now to question number 32. By the way, in case I made a mistake, please check me on this. I believe that I am correct, but the book, oh, you know why? Because this is not question 30. This is a hybrid of question 30. I combined two questions, but the solution will still check out. It's just a little more work than I was originally expecting. So let's go ahead and take a look at question 32 now. I'm going to kind of go over a similar problem, and let's make sure I write this one down correctly. M to the minus 2 plus 9m to the minus 1 minus 10 is equal to 0. So, okay, we'll let m, or let u equal m to the negative 1. U squared will equal m to the negative 2. Hopefully the u substitutions are becoming pretty consistent by now. This will give us u squared plus 9u minus 10 is equal to 0. My factors are going to be u plus 10 times u minus 1 is equal to 0. U plus 10 is equal to 0. U minus 1 is equal to 0. U will equal negative 10. U will equal 1. So we're going to go ahead and let m to the negative 1 put this back for u. Then m to the negative 1 is equal to 1. So when I multiply, so write this down, and then a separate time write down this work here. I'm going to raise each of these to the negative 1. So let me put a 1 under this on the inside because I'm going to flip this. So m to the negative 1 to the negative 1 will be m. That's the same. Negative 10 over 1 to the negative 1, that's going to be equal to negative 1 over 10. And then 1 to the negative 1, 1 over 1 just flips to be 1. And there are my two solutions for question number 32. And that, in fact, does check with what the book has. So there's just a couple of examples of how we work with these when they have negative exponents. Let's take a look at what happens when they have rational exponents. We're going to take a look at just a couple problems with each of these here and see how we address those. So two more questions. We're going to take a look at, let's take a look next at 34. So this is going to be w to the 2/3 minus 2w to the 1/3 minus 8 is equal to 0. So how do we look at this now? We're going to let u be equal to w to the 1/3. And as you probably guessed, u squared is going to equal w to the 2/3. So this is going to be u squared minus 2u minus 8 is equal to 0. When I factor this, this is going to give me u minus 4 times u plus 2 is equal to 0. I'll set each of these equal to 0. U will equal 4. U will equal negative 2. So I have two values of u. Once I have these values again, I know that u is equal to w to the 1/3. So I'm going to put w to the 1/3 as equal to 4. Here will be w to the 1/3 is equal to negative 2. Now, here I have w to the 1/3 equal to 4. In order to get this to be 1, I need to raise this to the 3rd. Same with this side. Over here, we have w to the 1/3. If I raise this to the 3rd, now I can have the 3rd root of something be negative, so that's not a concern at all here. Only if it was a square root would that be a concern. So here I'm going to get w as being equal to 64. Negative 2 to the 3rd, I'm going to have w equal to negative 8. So for 34, there are going to be my two solutions to that problem. So we're going to go ahead and take a look at one more question. This is kind of like the curveball question, so we'll make sure that you are prepared for it. It's going to be 38. And let's see what this looks like. It's going to be m to the 1/2 plus 6 equals 5m to the 1/4. So this is one of the later questions that covers this topic in the booklet, and I just want to make sure that you're ready to kind of tackle this and be able to answer these questions properly. The first thing we're going to do is we're going to get this equal to 0, and we need to get this in its rightful spot, in between 1/2 and here. So this is going to be m to the 1/2 minus 5m to the 1/4 plus 6 and equals 0. So now we have everything written in proper order. 1/4 is half of a half, so this is like a half, a fourth, nothing. Again, we're going to do our u substitution, so we're going to let u equal m to the 1/4. We're going to let u squared equal m to the 1/2. If I square 1/4, it'll give me 1/2. So u squared minus 5u plus 6 is equal to 0. At this point, I can go ahead and factor this as u minus 2 times u minus 3 equals 0. When I set each of these equal to 0, I get u equals 2, and I get u equals 3. So in this case now, u is equal to m to the 1/4. So I'm going to replace this with m to the 1/4. Now, just a cautionary note. Star this information. This is important. If these are negative, I can't do it, because there's no way to take the 4th root of something and get it a negative root. For the 1/3, that's okay, because you can get negative numbers when you take 3rd or 5th or 7th roots. Odd number roots can produce negative numbers, but even number roots cannot. Since both of these are positive, we're fine. So these we actually have to each raise to the 4th. So m to the 1/4 to the 4th will be m. 2 to the 4th is going to be 16. Here, same thing, m. 3 to the 4th is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So we have, not 80, 81. So we have two solutions for question number 38, 16 and 81. This concludes our lesson for section 10.5, or excuse me, 11.5. Please let me know if you have any questions on this in class. Thank you.